So Yanaga, over to you. We'll give Yanaga a little round of applause for everyone.
Okay, so second in a row. Now I'm going to talk to you about Kubernetes and for Docker and Java developers. How many of you are already using Docker? Some. Kubernetes? Some too. Well, I have to tell you that if you're not familiar with Docker yet, maybe some of the concepts I'm going to tell you won't make sense, because I'm saying, well, Docker is for one thing. Docker is for probably building your containers and something else. Kubernetes is a tool for running your containers into production. So I didn't prepare an introduction to containers and Dockers or something else, but I hope to be able to explain the concepts to you. I have another presentation that discusses these topics, but well, I think it's too late to switch right now. And well, introducing myself already. And this discussion, we're going to start with cloud computing. Cloud computing has changed the world that we live right now. So we changed some restrictions in the software development world, and now we're trying to uncover different ways of trying to solve the new problems that we created with this new technology. Okay, so in the cloud computing environment, when everything started, it's the same in any kind of wave of technology. You have the companies that create the technology, and they start to grow. Usually they have a huge market share. And the nice thing to see in all of this space is that as any technology evolves, first it's innovation, then you have like the peak of investment, then it becomes kind of a commodity, right? So providers, they start to fight, and when it becomes a commodity, these providers start to fight on price. So nobody thinks that like having an automated instance for you in a cloud computing provider is like a very true innovation. It's something that became a commodity. So all of the major cloud computing providers already provide that for you. If you go to Amazon, you have EC2. If you go to Google, you have the computing engine. If you go to Azure, you have the computing engine too. So you can have your own virtual machines out of box with just clicks. It's just a commodity. And if you're talking about this level of service, all of them will always fight for the price. In fact, both Google and Microsoft, they have the same policy. Whenever Amazon drops the price on their EC2 service, they drop their price too, because you're always going to pay the same value that Amazon pays. So it's a race to the bottom. So as a third the price decreases, everybody's going to decrease, and everything else. And the same applies for storage and blob storage, file storage, some basic messaging, and everything else. These kind of services are commodity. And now we're entering another generation of technology, which is containers. And we're talking about containers. Docker is the most famous provider for containers. Yeah, not because they were the first. Containers are very ancient technology, but I think the Docker allowed developers to be able to use container tools for their job. Because before, to create a container, you had to be root, you needed like special access, you need to know like very complicated Unix commands to be using this kind of containers. So the best benefits of Docker was to be able to help developers with their own user space tools to be able to create and run their containers. And another great point of Docker was that they created a website where you could publish and consume container images from other developers. So in the past, a container, you know, what containers do I have available? I don't know, you don't have a central point of information where you can just look up for the containers that you need. And usually the containers that you had in the past, the ops guys, they were creating the containers for you and you were consuming. So it was a very limited source of containers that you have to play in the past. With the Docker Hub website, I was able to publish containers there where other people could consume my software, and I could consume the software from the others. So now these days, it's just run a command, I consume these things and run in my machine. So it fits well the developer experience of using containers, But now I think we're entering the moment in technology that we want a widespread solution to be running our containers into production. So I think Docker solved the problem of the developer experience in boarding. But now we have different sets of challenges when discussing how to build and how to consume containers and how to run large-scale enterprise systems of this using containers into production.
Hey, are you enjoying our video? Excellent. In 2006, we set out to get all the Java community to come together to talk about the language they love. The Dublin Java User Group was born. From humble beginnings with pub meetups, we now bring in Java rockstars and Java champions to Dublin every month. With the knowledge they share, these are the guys that want to help you enrich your working life. So sit back, listen in, and study those slides carefully. They are full of gems. By the end of this video, if you've learned something fabulous or have ignited just one great idea, go straight to your boss and demand a DubJug membership. Just imagine what it would be like for you to be networking and sharing great ideas with 40 other Java developers at our next event.
And cloud computing, it happened in the past, it evolved, now you had the commoditization. And to be very honest, any software provider, any technology provider, if you're the market, you have the largest amount of the market share, you want something that we call lock-in. Like, for example, cloud computing, Amazon is the leader. They want lock-in because they don't want you to lead their platform. They don't want to commoditize the things because or else everybody's not making that much money. So you want lock-in, and everybody has this impetus of first trying the things on Amazon, but I think the largest threat to you is always lock-in. And lock-in, when they say lock-in, is not that, oh, you're locked in a prison with Amazon or something, because for many different companies it might be a good thing. For example, Netflix is stuck on Amazon and they're happy with their choice. But lock-in should be considered as a software architect is how much does it cost for us to change from one provider to the other? And the second thing is that, do I have the same amount of power to negotiate with Amazon if something doesn't work as expected? If they fail, or if the price gets too high, or if their services are not up to my expectation, or something else. So Netflix is different from us. And I think the best way for you to avoid lock-in is with open source. You need an open source solution that is able to run on different environments. For that, and not just because you want that to run on different providers, because that could be achieved by proprietary solutions too. I think the answers to this kind of problem of lock-in is open source too, because no matter how big your company is, no matter how innovative your company is, no matter how great engineers you have inside your company or in your provider's company, outside innovation is always bigger than inside. You always have more smart people working outside your company than inside your company. So it's open source innovation doesn't come just from inside. The majority of innovation comes from outside. And open source, of course, is not just about the code. Of course, the open source code enables people to contribute and to grow the innovation behind software. But the greatest thing about open source, it's community. It's the companies that are paying people to produce this software that is open source too. The users, they're able to get feedback. The community, as we say, user groups, meetups, developer conference, they're able to create and show to people different ways of using certain technology to solve problems. This is what community is about, okay? So it doesn't matter if you ever, I used to be one of the people that thought in the past, well, open source is just get in my source code and publish that on GitHub with a certain license. I have a lot of different repos and artifacts, for example, in Maven Central. And that was my way of doing open source. And some people are even using some of these libraries. But it's not good enough because you don't have a community behind that. I was just trying to solve my specific problems. And I had a very strict set of other people that had the same problems. That's why they're using some of those libraries. But the larger the community, of course, the larger the innovation and the largest amount of benefits that you can take from this kind of software. So when we're discussing about running containers into production, I think after this week we can all admit that everybody has chosen Kubernetes for running containers into production, except for one company, Amazon. Amazon doesn't want you to choose Kubernetes because Kubernetes is open source. Everybody else has chosen Kubernetes. Even the last one, the company that I thought that I would never adopt that, even them, this week, Docker company itself, they announced their support for Kubernetes. So everybody has jumped the Kubernetes train. So, and why is that? Kubernetes has a very interesting history. Kubernetes is an open source project that is sponsored by Google and developed jointly between Google and Red Hat. So the story that I've heard is that, and I didn't check the facts, so you can see, might be some fake news, okay? So, but the story I heard, I've heard that from multiple sources. It doesn't mean it's true too, but well, might be something. At least it's something that you can say, well, Yanaga was replicating some fake news later. And what happened is Red Hat was developing a container orchestration solution like 3 or 4 years ago. And when we open sourced the project on GitHub, and the guys from Google, they wanted to schedule a meeting with the Red Hat guys developing the container solution. And they didn't want to say why. Well, we want a meeting. Okay, if you want a meeting, why not? Let's get together and talk about that. And the reason was that the Google guys approached the Red Hat guys, said, oh, you just published the source code of this solution that you're developing on GitHub. We analyzed the source code. And what we can tell is we are developing internally at Google something that is very, very similar. You guys are using the exactly same concepts. So why do we have like these two big companies, these two developing the same exact solution just to compete against each other? Can't we just join the engineering teams to work on just one solution? And after the discussion, the solution was that Red had abandoned the project that was published and decided to commit their resources to work on the same project that Google was developing internally. So Google has been using containers in production, so maybe they know how to run containers in production because they have been doing that for more than 10 years. But not all of their technology was able to be open sourced, because you have a lot of intellectual property and you have to analyze the source code. So when they decided to open source the things, they had to start something from scratch because it would be very costly to just open source the thing that they had run into production. So Google runs approximately 1 billion containers into production every week. And that's why most of the people think that, well, choosing Kubernetes might be a good solution, because if they run 1 billion per week, if I run 10, yeah, maybe it's chaos, okay? I think that's a reasonable line of thinking. And so we decided to contribute. So Google hosts the project, pays the bills for the hosting and everything else. But today, like #1 contributor of Kubernetes is a former Google employee. He's the guy that created most of it, but now he works for Microsoft. And since he joined Microsoft, he didn't commit anymore. But he's working on something Kubernetes related. He's just not committing to the project itself. But I think that #2, 3, and 4 from the Kubernetes project, if you go to GitHub, these three guys are Red Hat employees. Okay, so Google and Red Hat are jointly developing the Kubernetes project, and mainly because, well, we started together in the beginning, but currently I think Red Hat is the one making the most investments on the Kubernetes core.
Jerry Nolan here from Stack & Co. When you want to change your job, you'll want to make a move which will give you career growth, interesting projects, and a fresh challenge. At Stack & Co, we can help you make that career enriching move by taking the time to really understand your individual interest and what represents the best next step for you. Let's have a confidential conversation to discover your career-enriching move. Contact me on www.stackand.co.
And that's the story behind Kubernetes. Kubernetes brought an innovative approach of trying to run containers production. And I say innovative because we had never seen that before Kubernetes, but of course Google was already using this kind of stuff internally. Kubernetes is just the open source version of the solution that they had internally. And we thought that it would be a great idea for that, but Google, as the people paying for most of the bills of the Kubernetes project, he has the right to make some decisions too. And Google decided that the only commits allowed on the Kubernetes projects are the ones that are useful for Google. So if you don't think if they think that Kubernetes they're not going to use the feature that's going there, they just, well, I don't think that's something that should be on the Kubernetes project. Somebody else should be doing that. And that's where Red Hat saw an opportunity for that. Because Kubernetes is not a PaaS, it's not a platform as a service. Kubernetes is a container orchestration platform. If you ever try to use Kubernetes, it's a very low-level tool for running your containers into production. And clearly, after Red Hat saw that, Red Hat only provides software for enterprise software companies, at least, no, not only, but I would say that 90% probably of the customers are enterprise software companies. And Kubernetes was too low level for these companies to be using. So we needed more developer-friendly features on top of Kubernetes for that to be usable by enterprise companies. And not only developer-friendly things, you think things about authentication, who is able to mess with which pieces of my running containers into production. It must be some division. You're only allowed to change this part. You're only allowed to change this part. And at Google, they didn't have this problem. At Google, my ops team can play with anything. Why do you need this separation? So Red Hat has had these problems, and they decide to build on top of Kubernetes. So if you think about the Red Hat solution to their customers running on top of Kubernetes is what we call OpenShift. So OpenShift is a platform as a service that runs on top of Kubernetes, which some people consider to be a container as a service platform. So Kubernetes is very low level, and OpenShift runs on top of Kubernetes, adding some features that Red Hat believes is important for enterprise companies. Okay? So if you look at the architecture, OpenShift is a container that runs on top of Kubernetes, which has something like a nice dashboard. Kubernetes, since I think 1.4, already has a dashboard too, but it's something that Google believed they didn't need to. But after many people complaining, they had to. But one of the first things that Red Hat added on top of Kubernetes was the console, authentication, support for database containers, because all of the workloads on top of Google were stateless. And well, maybe enterprise companies, they need to persistent state somewhere like a database system. So Red Hat added the support for stateful workloads on top of Kubernetes. And we're lucky that Google accepted the commits from Red Hat for this part too, because first it was a plugin, and now it's built on the core of Kubernetes. So we are developing these things together, and that's why, well, I work for Red Hat, so you know, you might put a grain of salt in what you're hearing. And that's why, well, we believe, or I believe, that OpenShift might be the best platform for you to be using Kubernetes. Okay, but what I'm going to show today is nothing like OpenShift specific. Maybe in the end some features that are more easily accessible through OpenShift, but most of the features I'm going to show you right now can be done with plain Kubernetes. But you're going to see that, well, it's a bit of work to be on the developer experience side. So I'll explain some basic concepts of Kubernetes for you. First, we have this thing like container. A container is a prepackaged solution where you can, traditionally, the traditional deployment process used to be, I have a server, I have to install the server, I have to prepare the environment. When everything has the right configuration, I can just copy my software artifacts, deploy that, and keep it running. So if I need to change anything in my production environment, if it's a configuration thing, I get this exact same server, I change the configuration, updated that. If I need to release a new version of my software, I stop the server, I copy the artifact, and start the server again. That's the traditional release process. With a container, I have the ability to package in one single thing the environment in which my application will be running and my software artifact by itself. So we say technically what we're creating when using containers is what we call a virtual appliance. So if you have a pre-packaged thing that contains both your environment and your application, that's what we call that a virtual appliance. So containers are the modern way of trying to create virtual appliance. In the past, we used virtual machines to create these virtual appliances, but it was so slow and so costly to be handling that almost nobody used that, right? But it used to be a good practice, but it was too costly. VMs are big, they take a long time to start up and everything else. So we know that for a long time, that the best way to release software is to package everything in a virtual machine. And if you want to release a new version of your software, you don't update your virtual machine. You create a new virtual machine with your new version of software, because if anything goes wrong, you have the previous virtual machine still running. But most of us didn't do that. With containers, it's much easier to be achieving that. So this is the concept of container. Kubernetes doesn't run containers. Kubernetes runs pods. And I know that for most of you here, it might be something very obvious or simple, but I have to tell, I'm Brazilian, I'm a native Portuguese speaker. For me, it was like, oh my God. Yeah? Because when I thought pod, why did they choose pod? I thought the pod was, they chose pod because they meant that the pod was a capsule, right? Containing something. A pod was a container containing something. Because in Kubernetes orchestrates pods and not containers. And what is a pod? Pod is a collection of at least one container. So we're talking about in Kubernetes terminology, we're saying a pod, we're scaling a pod. So all of the containers inside a pod, they have the same life cycle. If one of the containers dies inside the pod, the whole pod dies. Okay? If it gets restarted, all of them gets restarted, they all have the same life cycle. So a pod is a collection of one or more containers, even though most of the pods will have just a single container. But then my manager told me that. But you know that pods in English is the word for a collective of aquatic mammals. Usually use it for whales. So a pod is a collection of whales. And the most common format for containers is Docker, and the symbol for Docker is a whale. So it clearly became obvious why Kubernetes called it pods. But it wasn't obvious for a Brazilian, right? So I had like that aha moment. Oh my God, of course that's why it's a pod. Okay? But it's used for dolphins too, but clearly in this case they wanted to mean whales. So a pod is a collection of whales and containers in Kubernetes. So Kubernetes doesn't scale containers, doesn't run containers. Kubernetes only scales and runs pods, which can be one or more containers. And why would you do pods instead of single containers? You do that because it's easier because you might have some applications or some containers that have the same life cycle. But some of the greatest benefits, I think, are for resource management and sharing, because all of the containers on the same pods, you have the guarantee that all of them are running on the same host. Because if you're running containers to production, probably you have multiple hosts, you have multiple nodes in your system, because if one fails, you need the workload to move from one place to the other. Probably you don't want all of the instances of your application to be running on the same host. You want to distribute that in case of failover. But if you have two containers in the same pod, they are always running on the same host, and they can always communicate through localhost.
I'm Catherine Asko, the founder of Guru Team. Guru Team specialises in delivering high-end ICT, technical training and consultancy services. What makes us different is that we employ the creme de la creme of specialist instructors who have vast real-world experience and passion for the technologies they teach. With a continually evolving portfolio of over 250 courses, we can customise a programme to suit your team. We have one of the largest portfolio of cloud, Linux and development courses in Ireland and have several accreditations including the Linux Foundation, LPI and the DevOps Institute. We would be delighted to talk with you about working with your teams, so please visit our website on www.guruteamirl.com.
Okay, you can communicate with them through sockets or something like local sockets in the file system. You don't need to go through the whole network stacks that way. So it's much more performant if you need like these two containers to communicate very closely to be running inside the same pod. And you have other reasons for that too. I had a very bad example of why I should be running two containers in the past, but later I'll be able to show you a much better explanation for why do they use pod. It wasn't obvious until some very few months ago, but now we have like production features that are like meant to be run inside pods. Okay, but I'll leave that to the end. Another concept of Kubernetes, you have labels. If you use Gmail, you have labels. You can attach multiple labels to your pods. So why is that? Because maybe if you have one application running in your Kubernetes cluster, really doesn't matter. But if you're running like 50 applications in your containers, if you have multiple things inside your containers, well, maybe I want to scale this set. How do you select only that part of your system? Well, you need labels. So you apply labels to differentiate workloads from one to the other. Replica sets, which is a very interesting concept. Replica sets means when you said, well, I need to run this application. You can tell Kubernetes that I want at least 3 instances of this application running to production into any given moment. And you can add like very interesting things like I'm saying that this application particularly is a very data intensive application. You can add a label to that replica set. Say it's a data intensive application, it is IO bounded or something, because these labels, this information will help Kubernetes to choose the right place to run your application when decide to schedule the execution in your nodes. Like you can have like a node with high memory, you can have a node with SSD disks, you can have a node which is close to the border, so it has a faster network. You can have different set of requirements. So if you put this information on the replica set, Kubernetes can use this information later to better run your containers into production. So, but replica sets, the most trivial thing is that it allows you to scale your pods. You can say you need at least 2 or at most 5. These days, we also have like auto-scaling features. You can ask some metrics from the Kubernetes cluster and say, well, if any pod or if any node consumes like 80% of the CPU, maybe I want to scale more of that, and instead it can scale up to 10 instances inside my cluster. And depending on where you're running your platform, it can scale the number of hosts too. So if you're running on, it depends really if you have the right plugin for the platform, but if you're running on Amazon, for example, or OpenStack, you can say, I have a Kubernetes cluster of 5 hosts, but suddenly all of my 5 hosts, they became overloaded. If you have the Amazon plugin, you can ask it will automatically create another node on Amazon EC2. It will install Kubernetes on there. Yeah, when I say install, not really install. It's going to get it ready for you to run your workload, and it's going to distribute there. And after your workload rate drops, you can tell that to automatically drop that instance too, because Kubernetes automatically reconfigures your cluster. Okay, so that's some of the abilities that you can have. You can also have the concept of deployments. This is one of the features that Red Hat contributed to Google, because in the beginning it was just replica sets saying, oh, run this application, and doesn't matter. But you know, most of all of us, enterprise software developers, is not just running an application. I'm running version 1 of this application. Now I want to update version 2 of my application. But I don't want to lose all the configuration that I did on version 1. I don't want to specify everything all over again. I'm just saying that I'm updating the software artifact of this same thing, so the number of instances into production is going to be the same, and all the other stuff. If that's a stateful application, if it needs to access the file system, it's going to keep accessing the file system too. So Red Hat developed this feature and contributed to Kubernetes, which is the concept of deployment. Deployment means that you can create an application, and this application has multiple versions. So you can ask, well, I update this application. So Kubernetes will track the history of the deployment. And the deployment has a replica set, which is the thing that runs into production, okay? Services, another thing is that if a replica set, you don't even know where your instances are running, because if you have 5 hosts, you might have 1 container here, 2 there, 1 here, and none here, or something like that. You need a way for you to access this endpoint. So if you have an HTTP application, which IP should I go to access my application? You shouldn't know, since it's a distributed system. So what Kubernetes does, Kubernetes creates an endpoint. In Kubernetes terminology, you just ask for the endpoint, and Kubernetes automatically gives you the remote endpoint without you to having know the specific IP. So services inside Kubernetes, it is implemented as a DNS query. So if you want a database service, you just ask for the database host, and Kubernetes automatically will answer to you the IP of the current instance that you'll be accessing. And you can guess, Kubernetes automatically load balances the request for you. You have different strategies. The default strategy for load balancing the instance is round robin. But if you want, you can apply other types of load balancing inside your Kubernetes cluster too. So, yeah, and this, the fact that Kubernetes uses DNS is a very good thing, because you don't need to install another service broker inside your architecture or something. Anybody here ever used Netflix OSS Eureka? Okay, Eureka, a service broker. You need to install, you need to announce that you're joining, installing. You need to announce a new service to Eureka so other people can consume and everything else. Eureka has other features that you can use. If you tie that to Ribbon, you can use like client-side load balancing. But I think I agree too. The default version of just using DNS for your queries and service brokering, I think it's a much easier solution. You don't need to install any additional piece of software. You just use DNS host like you've been using in the past 40 years, 50? Yeah, it has been a long time. Health checking. Also, Kubernetes is not only about running things into production, it's about making sure it is running into production. So Kubernetes automatically has built-in support for health checking, which means, is this pod running? So the default way of Kubernetes to check if a pod is running, if that's an HTTP endpoint, Kubernetes first asks the Docker daemon if the container is running. If not running, it's dead. Second step, Kubernetes connects to the TCP port of the endpoints. It connects, it goes through the next check. And if that's an HTTP endpoint, it tries to get a response. It asks for the URL that you specify in the configuration. And if it returns anything between 200 and 399, Kubernetes considers that pod to be alive. And you can determine, well, Kubernetes, check this pod every 5 seconds, every second, every 10 minutes or something. You just configure what is that. Because if Kubernetes tests the pod and if it's not alive, it automatically reboots the pod. Or if Kubernetes determines that, well, I think it's not good to be running this pod on this host, it automatically just migrates your workload for another host, because you said on the replica set, you said 3 instances. If this one is dead, Kubernetes is going to start another instance automatically in another place.
What if it's not an HTTP service?
It's not. It's just there's support for another protocol too, but if Kubernetes don't know, if it's just TCP, it just tries to connect. If it connects, then it's alive. But again, you can implement your own plugin to check for the healthy of your pod, but I know that by default, at least, well, things change very fast. Last time I checked it was only TCP, connect, and HTTP does this test. I don't know if they added support for other protocols, but the other protocols are not that common. Right?
Like if you have worker services, but just consume messages.
Okay, then for worker, probably you would you could always create HTTP endpoint just for health checking. Okay. Yeah. It wouldn't be hard. Or you could just rely on the Docker daemon telling you that it's running, which is not always a good solution. But I think, well, my line of thought, I would rather add an HTTP endpoint. I think it's easier than try to create my own health check protocol plugin. Yeah.
Hi there, it's Sergio Dobrovolsky here from Version 1, an IT consulting company that has a main focus on innovation. We believe that innovation is a key factor in being successful. That's why we created an innovation lab, a place where we can experiment, try new technologies, express ourselves. So in order to bring more value as possible to the company and to the community as well. If you're looking for new challenges and if you want to experiment the innovation with us, don't be shy and come and talk to us.
It might be easy. And health checking, I say, Kubernetes still has two different kinds of live check, because people realize that you have two different states of your application. Your application can be alive, but is it ready? Which means usually when you start up your application, you know, especially if you're a Java developer, you know that sometimes your application servers take some seconds to be able to reply. You're just waiting for it to warm up. So Kubernetes first test, is it alive? It's running, but it's still slow. It's not ready to be receiving production requests. So Kubernetes has another check, which is the readiness check. Readiness check tells that, well, you need to access this endpoint, and this endpoint needs to reply in 10 milliseconds. If any response gets more than 10 milliseconds, this pod is not ready. It's alive, but it's not ready. So whenever it will only be able to receive production requests when it's ready. Okay? So you can specify the configuration. So usually now in the replica sets, when you say you need 10 instances of this running into production, means you need 10 instances ready, not just 10 instances live, which used to be the default in the past. And how do I use that? So now I'm going to show you how can you use these commands on a Kubernetes cluster. So before that, let me show you here. All of the demos that I'm going to show to you are running on top of a local Kubernetes instance. If you ever try to install a Kubernetes cluster, it's a bit hard. You have a lot of things to do. And that's why most of the people gave up and tried to run a Kubernetes instance on their notebook. First, because it's heavy. Second, because it's hard. And if you want to update a version of their Kubernetes cluster, it's even harder. And you don't always have the connectivity or the resources to have like a Kubernetes cluster available for you on Amazon or somewhere else. So that's why at Red Hat we developed this thing, the Red Hat Container Development Kit, which is an out-of-box solution. So you can just download and install that. It automatically creates a VM on your virtualization solution. If you're running, usually the default is VirtualBox, but you can use other alternatives. Like if you're using Windows, you can use, oh God, what is the name? Hyper-V. You can use Hyper-V. If you're using Macs, you can use X-Hive too. So you can choose. If you're using Linux, you can use Zen. So it really depends on your solution, but by default, it's VirtualBox. You just install that. You automatically have a console to be developing and running your applications. And why did we do that? Because, again, not everybody had a Kubernetes cluster available to be tested. And you know that it's very important for you to develop and test your applications on the same environment that is going to run into production. So you can't just expect your application, I'm testing my application on a Mac, but my production environment is a Linux running on top of Kubernetes. How do I emulate the Kubernetes service or Kubernetes health checking if it's going to work properly in production? You need to have the same environment. And another bonus is that most of the enterprise companies, they run Red Hat Enterprise Linux into production. So if you want to create your containers using Red Hat Enterprise Linux, you can use the Red Hat CDK. You have your own distribution of Red Hat Enterprise Linux running on your laptop. Okay? I don't know how many of you were aware of that, but it has been more than more than 1 year and a half, to be honest, that Red Hat Enterprise Linux is free for developers. So you just have to pay for subscriptions. Now it's available for free. Not only Red Hat Enterprise Linux, all of the Red Hat software portfolio is available for you for free for development purposes, okay? You can use your subscription for free. You can just go to this website, developers.redhat.com. If you sign up, you can access all of the Red Hat portfolio for free. In fact, even Red Hat enterprise companies, I visited another company, which I don't think I can disclose, but it was a big company, present in many different countries, in Europe, in other continents too. Of course, they had a lot of money and they are a big customer from Red Hat. What they told me is that, well, we have like unlimited license of JBoss EAP, data grids, and JBoss messaging and Red Hat Enterprise Linux. But every time we needed a new virtual machine, we need to ask the ops guys, and the guys took like 1 month to give us a virtual machine with the Linux, and later we had to ask them to configure that. What they did after they realized that now everything is free, they created their own account with their Gmail addresses on here, and now whenever they need a new virtual machine running Red Hat Enterprise Linux, they just spin on their own computers and install the Linux by themselves, because they don't want to wait 1 month for the ops guys to provide the virtual machine for that. Because now they have, and it's exactly same bits. Red Hat CDK is built on top of Minishift, which by itself is built on top of Minikube. So, Minishift. Which, again, everything is open source. The difference between Minishift and the Red Hat CDK is that if you're using Minishift, the Linux distribution running on top of Minishift is CentOS, right? Which are the same bits, but not the same binaries. Same source code, but not the same binaries. If you're using the Red Hat CDK, you're using Red Hat Enterprise Linux. Okay, that's the basic difference between these two projects. And well, Minishift is it's an open source project, but nobody's backing the developers behind, nobody's paying salaries for them. With the CDK, we have our own engineering team, we have like a QA team. So usually CDK is more stable than Minishift. But as any open source project too, we test things first on Minishift. If it works, it goes on CDK. So the beta is always Minishift. Okay, so that's why we're going to see some examples of how can we use Kubernetes. So I'll give the basic commands, then I'm going to show the basic. So if you use it to, for Docker, if you want to run a container in your Docker host, you execute docker run -d detach, restart always. You want it to be running even if you restart the Docker host. You give a name for that, you map the ports to be accessible, and you give the name of your application running. If you want to do the same thing with Kubernetes, first kubectl run, you pass the image and you say that it uses port 80, but by default in Kubernetes, the applications running on top of Kubernetes, they're not exposed by default, because you don't want every application to be exposed, and you think that the decision to expose your application or not should be done later, and not by the time you run your application. So Kubernetes, you need 2 steps. First, run your application, and if your application should be externally accessible, you expose it. So I'm going to expose my application to the outer world, okay? This is the basic of Kubernetes. And Kubernetes only allows you to access these applications through the IP address that is running the load balancer of your application. We thought that most application developers, they don't use IP address. So OpenShift adds to Kubernetes the concept of a root. So if you add a root to your OpenShift cluster, OpenShift automatically routes the DNS host name of your root to the running backend on top of Kubernetes. I'm going to show you how it works, okay? But it's much easier to work with names than IP address, especially because the IP address can change over time, but the name never changes. Docker PS, if you want to see the containers running, you don't have the only containers running on Kubernetes. You have a lot. You have deployments, you have replica sets, you have applications, you have services and everything else. So to kubectl get in what you want. If you just want the pods, get pods. If you just want the services, get services. If you just want the deployments, get deployments. And most of them, they have shorter alias. So you don't have to type the whole word, get deployments or get pods. But not all of them have alias, okay? If you want to access the logs of a certain running pod, Dogger logs -f, kubectl logs -f2. If you want to execute a certain command inside a container, a running container, docker exec, kubectl exec2. But usually, when you run something inside a running container, you do that for debugging purpose. You want to know if a certain file has been written or a log file. Docker stop to stop the container, rm to remove the application. Kubectl delete replication controller because since Kubernetes uses the concept of a replication controller or replica set, if you delete a pod, Kubernetes, the replica set says, I need always at least 3 instances running, 3 pods. If you delete a pod, what happens? Kubernetes just creates another pod, right? So it's useless to delete a pod. You need to configure the replica set.
Hi there, John Bolger here from version 1, an IT consulting firm that grew from 2 people back in 1996 to over 1,000 people today, with 100 Java developers alone. Core values is something that we take very seriously in version 1, and is ingrained into every decision we make and into our culture. If core values and strong principles is something that interests you, then we would love to hear from you. You can find our website at www.version1.com. Enjoy the rest of the video.
So it does that for you. So I can tell you can delete the replica set to remove everything, but usually you don't want to do that. You just reconfigure the replica set or replica controller. Yeah, that's what you do, and get a CVC just to check if everything went out. If you want to delete the service, you delete it too. And now, time for the code. Now I have to sit, and hopefully I won't smash this, because I'm recording here with a phone on my back pocket. No, I want it to survive. And I have a Minishift instance running here in my notebook. If you want to start it, you just say Minishift start, we spin up a VM for you. If you want to stop it, you just stop that. But I already have it running, because by the first time you install it, it's going to download some container images. It's going to download the OpenShift and Kubernetes images from the registry. But I have here my Minishift instance running. Okay, and I have to look at my notebook because of the delay on the screencast. Okay, and if I want to see, well, I have it running because if I ask for example, kubectl get pods, it works. But if you want to use the OpenShift commands, you can use the OC command line, which is the OpenShift client, get pods. It works the same because the OpenShift command line client is a superset of the Kubernetes command line client. So everything that you can do on Kubernetes, you can do with OC2, but the opposite is not true because OpenShift has more features than that. So I'm going to use OC because I want to show you more features, but all of the commands that I am showing you now, except when I note that, you can use using just kubectl, because
sorry, quick question. So I think when you do that kubectl get pods, it basically pulls the pods from the default namespace. So there's another pods of the namespace.
yes.
So you could see basically there are other pods probably running, but you need to specify the namespace, right?
Yes.
The system, right?
Yeah, I forgot to tell that. You have the concept of a namespace, which you can consider like could be a DNS subdomain. Then you can partition your workloads between different namespaces. Different teams can be using different namespaces. And I don't know if it changed, but in the past, the OpenShift called the namespace a project because it adds more feature to that. But in the past, kubectl, if you wanted to change a namespace, you needed to keep specifying -- namespace, something, yeah, which is very boring. And OpenShift assumes that the last namespace you use is the one that you want to keep issuing commands. Okay. And let me see. And if you want on CDK or Minishift to show the web interface, you just type Minishift console. It will open the console for you. I already logged it in. By default, you have two different users. I strongly suggest you to use the user developer, password developer, because you don't want to mess with your cluster. But if you do, you just do Minishift delete and Minishift start. It will create another VM for you, because I've done that a couple of times in the past. Okay? Because if your system, you can mess with the entire cluster. So in Kubernetes, they call namespace and OpenShift is project. So if I go into my projects, I can see there's nothing here yet. So the OpenShift way of using that, so in OpenShift you have authentication, so you can do a login. I'm already logging in, but I'll log in again. Developer, and I'm using by default my projects. But if I created a new project, or see new project, Yanaga, I just created a new project, and now since I just created a new project, OpenShift assumes you want to use this new project. By default, of the commands right now are going to be issued against the new project. So Yanaga, which has nothing again. Okay, so if I want to run an application, I'm gonna get here, run port 80. So what I'm going to do, kubectl or OC, run image. I have some pre-built images. I'm going to show you later how to create your own images here. Image is Yanaga, deploy master blue. Dashboard, I think it's 8080. The name of application, which is deploy master. So I just created a new deployment config, and now the deployment config is going to have a history. I'll be able to update the version of that. And if I go to console, I already have my application here. It's running fast because I executed this before in the past, so it's already cached. Okay, but if not, it would have to go first. OpenShift already installs an internal Docker registry for applications here. It first looks in the internal Docker registry for caching purpose, for example, or if it's not local, it goes to Docker Hub. Okay, I think it also goes to the Red Hat's container registry too, and then to Docker Hub. I don't remember the examples, but since I'm only using the images that I've built myself and uploaded to Docker Hub, that's an important thing that I want to show. This image came from Docker Hub because I published that before. If you go to here, these are the images that I'm using. I'm using some tags, so I deployed the blue tag. And you might be wondering, what is this application? This application is just a white font with a dark background, which is blue, green, yeah, the colors. Because you just want to, and it's 162 megabytes, okay? Just for a plain HTML screen, because that's a Spring Boot application, right? You can't shrink more than that for the basic things. So I just ran here. What else do we have here to run the application? If I want to see what is happening, I can get OC get pods. OC get deployment. C get DC, deployment configs. I have one. Is it too small? I can increase here. No. Okay. Deployments, OC get services. I have none because I didn't expose my application. So, if I want to access my beautiful blue endpoint, I can do that through the command line. I can see OC expose replica sets deploy master. But when I expose, it's not that easy because I need to specify which type of the load balancer to, and if I want to access later through name, I have to specify the host name and everything else. So to be very honest, I can do that for the command line, but I find it much easier to just go here to the console. If I get actions. Oh no, the service I need to create. Let's see, create service, expose. ARS deploy master. Replica set DC. I just exposed DC, and now, okay, it's running. Now I want to expose this through a host name. Create root. That's the thing that OpenShift builds on top of Kubernetes, because I want to access this thing through a namespace. And by the, I just assume the defaults, create here. After I create that, I can see deploy master dash Yanaga, which is my project. I have the IP address, which is the IP of my Minishift running instance, the IP.nip.io, which is a service which just applies the IP that is typed in the URL. And if I open it, hello from blue. Okay, a very complex application. It's consuming half a gigabyte, just to show that. Okay, that's why Java is very light.
Hi, my name is George, and I'm a Scrum Master at the Equifax R&D Centre here in Dublin. We focus on innovation and collaboration, and have a fast-paced, team-driven environment where everyone is a key contributor to high-priority initiatives. We have a very healthy and vibrant agile development community where there is a focus on automation and CI/CD to ensure that the highest standards of quality are maintained. If you would like to learn more about us, please get in touch through our website, which is equifax.com.
And that's the basics. So I have this application. Maybe I show you blue. Maybe I could run another application, or maybe I could scale that. I can scale through the interface. Now I want at least 2 pods running. And you can see here in the interface, you have Kubernetes scale. Now 2 of them are running. I have 2 running instances. If I access here the endpoint, you're able to check that Kubernetes automatically load balances within WAN. But in OpenShift, the OpenShift load balancer is sticky by default, which means that if you create a session, it's always going to the same backend. I believe that in Kubernetes, it's just round robin. So that's another feature. If you want the OpenShift router to be non-sticky, then you have to configure that. Okay, so that's what I did. And I want to show you, for example, we had blue-green deployments. If we want, we can manually do or create blue-green deployments using Kubernetes. So what we're going to do right now, I'm going to create another deployment. So we'll see run green image Yanaga deploy master green, and the port is 8080. I created a new another deployment. You can see my application. It's still orange because since I didn't run this application before, it's not on the internal OpenShift cache. I'm going to say OpenShift because Kubernetes doesn't have cache. OpenShift has a cache. And once it downloads this image from Docker Hub, oh, it was pretty fast. The network here is very good. Once it downloaded, it just started the application. What I want to show you is that this application, it has not been exposed yet. So the only application that is accessible in my my Kubernetes cluster is this one, which I can access through this endpoint, which gives me the blue one. And what I want to do right now is I'll expose. So oxy expose DC green. Now this application is accessible through other applications inside the cluster, but is not accessible externally yet. So what I want to show is I can easily create, this is an OpenShift only feature. I want this route to create a blue-green deployment saying that, well, maybe I can route part of my requests between this blue and this green one, and how can I do that very easily? So what I can achieve here, I will create another route and say that my route is blue-green, host name. Which service do I want to deploy to? I want to deploy by default to the deploy master one, but I want to split my traffic between other endpoints, and I want my other service called green to be accessible too. And in the beginning, I want to route that 50-50. Okay? So I'll be load balancing between the requests. So I just created the blue-green host name, and you see it's blue right now, but if I keep hitting refresh, nothing will happen because what I said, it's sticky. I have a session, it got on the blue, it will keep blue running. So if I want to change that, I could open another browser. Let's see if Chrome works. No, I have to do with another browser. Which got, again, the blue. Well, let's see. Green, okay? I just had bad luck on Firefox. So now the other session that I created, now it's accessing the green endpoint. But this is what I'm doing. I'm load balancing the requests with sticky sessions between these endpoints. If I want to perform a pure blue-green deployment update, I want to test the other endpoint. So if I go here and test the deploy master endpoint, which is the old one, which I didn't configure yet, now it's accessing the blue endpoint. So I want to, here, I want to, I can do this in two different ways. I can just patch my Kubernetes OpenShift configuration using JSON patch, the JSON patch specification, or I can edit the route through OC edit route deploy master. And I say this is the OpenShift configuration for that, and I'm saying that service, all of my requests are going to the service called deploy master. But I want to change that. I want to say that all of the deployments must go to green. So if I say that and I save it, if I did any mistake with my configuration, OpenShift wouldn't allow me to save the file. It would reject, it would still keep open. But since everything was okay, I just edited the route. And if I go back here to my deployments, it's green. Or if I want to do that back again, but now I can do the patch way. I want to patch the route deploy master, and it's going to the one that is called deploy master. Patch it. What did I do? Let me edit. You can always check here, right? Oh, deploy master is right. No, blue. I just needed to hit hard refresh. So now it's accessing to blue. And the one here, blue-green, let me edit here through the interface. It's splitting, and I can easily say, well, I want like 10% of my requests go to the deploy master, which is the blue one. The other ones I want to go to the green. And if I save this, Of course, I don't want to open 10 browser instances just to check if one of them is going, so I'm going to use a curl script for that. And I want to curl my endpoints called blue-green-Yanaga. I need your blue-green-Yanaga. I'm just going to change the URL here. And it issued 20. Oh, no, now I'm lying. 1, 2, 3. 3 from 20. It's more than 10, right? Okay, but I guess the router is just bad in math, but it's working, okay? It's issuing more than 50% of requests to one to the other. Or did I screw something? Maybe. Edit. Yeah, 90, 10. Well, should work. You know? That's how you know that it's really a true demo. It's not a video, because it doesn't work the way you're expecting.
Maybe if you send 100.
Yeah, maybe it's just such a small number. Well, I don't know. To be very honest, the past times I did that, it worked the way I expected. But of course, we're in Ireland and something had to go wrong. Okay? And that's the deployment. I think I patched the wrong one in the past. It might have mixed something, I don't know. But here it's showing like 90 and 10%, which should be the correct behavior.
Equifax is a great place to work for, especially to develop your skill set as a developer. The company culture and the office atmosphere and the location are all perfect. A lot of our projects actually focus on big data and the cloud, so we use a lot of cutting edge technologies in our projects. So you'd see things like Java 9, Angular 2, AWS, Docker, and recently the ELK stack. You're constantly working on projects and products that are actively used every day, so that you know that your work actually means something. So if you'd like to learn more, get in touch and log on to equifax.com.
What else can we get? Logs. I could get logs from my deployment, but if you want to go through a nice interface, you can just go here, enter the pod, and you have the logs directly from the interface. Right? So
is that not very heavy?
Well,
like when you're not viewing those logs remotely?
Directly from here?
Yeah.
Oh, good. Well, it just, you can also follow the logs if you want to go. It does the log aggregation for you if you get the, let me go back here. So if you want to get this green one, well, heavy. Well, to be honest, this is a very nice tool for debugging that specific pod. I want to see the logs, because if you go to production, you're not going just to use that. You're going to send the logs to a log service, so you can index and everything else. But as I said, this is a nice feature to have, but production, nobody will be checking exactly. But it's much easier than using the kubectl exec command just to go into that specific container and tail the logs. So I think that's why they created this feature. Okay? But if you still want to go into that container and execute something, this terminal, it runs a bash for you. So now I'm right inside the container. I don't have to type anything. I'm just here. I have the blue-green jar. I have my containers. If I had a log, I don't know where is the log, but it's right in the log somewhere else. And var log. It would be right in the log file. I can just cat it or tail inside here. Okay, so this is the terminal. Disconnected now. Logs, you can have configuration environment too. If you want, one of the good practices for your application, you don't want your application to have the configuration of the database URL inside your code, so just because this is something that belongs to the environment. And if you want to expose this kind of configuration to your application, you can do that with what we call a Kubernetes config map, which is exposed here in the environment variables. I'm not using that specifically, but in Kubernetes terminology, I could just, let me see, edit the YAML and add the config map here directly. Then I would need to know the syntax. But you might be wondering, but what if I want to propagate the database passwords? I don't want that to be in a plain variable where everybody can just go here to the console and see the variables. So that's another thing to the Kubernetes added, what we call Kubernetes secrets. So you can safely expose like private sensitive information like database username and passwords to your configuration environment, and it will be hidden. Yeah, so I won't be able to check here if the environment is okay or not, and you can use the same environment configuration for different multiple applications, because every time you change your database configuration, you don't want to change the URL in all your applications. You just create one config map, and you tell all of your applications in your system to use exactly same config map or secrets from Kubernetes. What else? As I showed the terminal, to delete things, I could delete just to get the pods here. Or get pods. I have 2 instances of the deployment master running. As I said before, it's just useless to delete a pod, because if I delete this pod with this number, you can see that Kubernetes is automatically detected that it only had 1 instance running, is already creating another instance of my pod, because I specified that I need at least 2 instances into production. If I go here, probably it's already up and running. Here it's complaining that I should have a health check. If I add a health check, you can see readiness probe and liveness probe. If I want to say my application is live, I just perform a get on this path of our application, use import 8080. The initial delay before checking if it's alive or not, I'm going to take 0. The timeout for it to reply should be 1, 2. If I want to add a readiness probe, I say that, well, maybe I can access the same point, but the timeout is 5 or something like that. You can configure the way that you need. It can be and should be probably different paths. What we suggest is that on the readiness probe, you just create, for example, a query against your database, and if you it should take some time to process that. And if it goes okay, then the application is ready and warm. So now it has a health check. If you don't add a health check to your application, what might happen to that is that, well, you're scaling your pods. Kubernetes has just created a new pod, but it's not ready to reply. So a client issuing requests against your application will suddenly see that stuck browser wheels waiting for information from your backend, and you don't want that to happen. So that's why you need a liveness and a readiness probe. Get pods, and yes, delete. Well, I guess I covered most of the stuff. What I want to comment with you right now is that in the latest versions of Kubernetes added what we call cluster federation. In fact, I have to tell a very nice story about that, because before joining Red Hat, I visited one of the largest online and brick-and-mortar retailers in Latin America. One of the largest, no, the largest online and brick-and-mortar retailer of Latin America. And they decided to choose Kubernetes exactly because it was open source, and it allowed them to have portable workloads between different cloud providers. Because in the beginning, they chose Amazon, and they were stuck with Amazon. But suddenly, the bill increased so much that we say, well, we're paying too much to Amazon, but we stick to them. We can't. And Microsoft approached them and offered like a much better deal, but they just couldn't accept it and they were often like, we want to give you like 200,000 reais of free credits just for you to try whatever you want to try. And they said, we can't even spend the money that they're giving because our workload is stuck in Amazon. So what they did, first they ported their application to containers. They decided to deploy a set of services into Kubernetes, and they did a test of application portability. They created a Kubernetes cluster both on Amazon and Azure. So when the day came where I thought everything was ready, they ported all of these smaller services into and one crucial service. It was some surrounding services and one crucial service, because it didn't need the database that was on Amazon. So they ported this service with one command. They dropped the workload from one provider to the other, and it worked. Yeah, so they did that on a weekend, and the next Monday they were able to call Amazon and say, oh, we want somebody to come here because maybe we need to negotiate some terms because we're not tied to you anymore. So they still running Amazon, but they got a much smaller bill just because they had the opportunity to negotiate. Well, the other guy is offering me this. What do you offer me now? Because now I can move. But they did that manually because the version of Kubernetes that they were using at the moment, they didn't have cluster federation. And cluster federation allows you to have multiple clusters running on different providers, for example, Google, Amazon, and Azure. And you can automatically move the workloads between providers. So the cluster federation automatically decides. You can establish some parameters. If this becomes too expensive, move to the other. If this becomes low, move to the other, anything else. But they decided they didn't want to try federation before anybody else with a big deployment like them have shown that in public that it's working. They don't want it to be the beta testers of Kubernetes Federation. So right now they have a workload portability, but they still need to type two commands, okay? Which is drop the YAML file from one cluster and upload to the other. So they still need to do that. They plan to deploy cluster federation as soon as anybody announces that it's using into production. They don't want to be the first in this case. It's not always a good thing to be the first. Okay, so they're playing on the safe side. And the last thing that I want you to take notice is that it's 2017. I know some of you have heard about Netflix OSS and even using that into production. What I'd like to say is that we're very grateful for Netflix for doing creating the Netflix OSS stack, because it solved a really hard problems for them, and to publish that as an open source project. But I'd say that Netflix started this project in 2009. They released the very early first release of their open source stack in 2012. So it has been already 5 years after we had the first world-class solution for distributed systems, and in particular microservice. A lot of things have changed in the past 5 years, and what I like to say to it, the Netflix approach of solving these distributed system problems is trying to solve that on the application level, or in the business domain level, because it's really part of their business, of Netflix business doing that. But since we are in 2017, and the evolution of technology happens like that. First, you have a problem, you need to solve that in the application level because it's the layer that is easier for you to fix things. But once the knowledge consolidates, now it's working perfectly fine. You always push this solution to lower layers. So first things that you do, you push that to a library, so other people can reuse that since it's a proven solution. That's what Netflix did, for example. Right? Many solutions, they push that to libraries. Other solutions became even more consolidated, so you push them to services. That's what they did when they published things like Eureka, for example, like a service broker. So the more consolidated the solution, the lower the level that you want to run that kind of things. So in 2017, the way that we think that is appropriate for you to be solving these distributed system problems is with something that we call Istio, which is kind of we call that service mesh. And Istio, you can run that in different configurations, but the underlying layer of Istio works that Istio creates a sidecar container of your application. What is a sidecar container? Remember that a pod allows you to have multiple containers running together with the same lifecycle. Istio creates, I have my application, Istio adds another container to your pod. And we call that sidecar container because this sidecar container doesn't do anything by itself. It's just a helper. And what does it add to your application? It automatically adds client-side load balancing. It automatically adds you service discovery built on top. If you want client-side load balancing, usually you want to tie that with something else, like another form of service discovery. It automatically adds tracing. It automatically adds like log aggregation. Automatically adds like circuit breaking, which is the ability for you, oh, this endpoint's not working, maybe I need a fallback for that. And you don't need to add anything in your code. You just add Istio and ask Istio to add these features to your applications, and it already automatically runs on top of your infrastructure. This is the thing that people are talking about today, because we truly believe that this is the thing that is going to be the default way of solving distributed system problems in production environments. Not in the application level, but in the infrastructure level, because these problems are considered to be solvable now. They are consolidated. And you can use Istio, which is a solution that many different companies are betting on. Companies like IBM, like Red Hat, and who else? 3 big ones. Oh, Google, IBM, Red Hat. I think it's, I don't know if there's another big company. But they're betting on top of this. Even talking about some, today, Istio is a separate problem. I've talked to some of the Kubernetes engineers. They're thinking that Istio will be the solution for now, but in the long term, they might even, Istio will not even be a separate service. Will be embedded inside Kubernetes, because it will be so consolidated that you want to run application production. You don't ask if people want circuit breaking or tracing or something. It will just be built in Kubernetes. But so far, Istio is a solution that runs on top of Kubernetes. It's not part of Kubernetes, at least not yet. So this is one way of trying to solve that. Another nice solution that I have to show to you is that the container behind Istio by default is Envoy, which is a solution created by Lyft. Another solution that can be used with Istio is Linkerd, right? It can work as a sidecar container or as a node proxy. I don't want to dig into complicated details, but both can be used for the same thing, but they solve the problem in a slightly different way. The problem, Envoy is built, is coded in C++, so it's very fast, very lightweight. Linkerd is coded in Scala, which means that it consumes a lot of memory. Okay, so that's one of the disadvantages of Linkerd. So that's why Lyft Envoy is used as a sidecar container, because you have one container, one sidecar, one container, sidecar, because it's very small. Linkerd is used as a node proxy. It means that each node in your cluster has a copy of Linkerd, right? And it makes sense from some use cases that I don't want to explore too much, but saying, if you're caching some information from a service, cache for example, if you cache information, you don't want, if you have 10 instances of your application running here, you don't want 10 sidecar containers, each one of them with a copy of the exactly same information on a cache, right? It's just a waste of memory. So maybe you want this information per host, because all of the nodes in the system will consume the exact same thing, and since everybody is on the same host, they have the same latency. So cache, for example, is something that usually is better served as a node proxy rather than a sidecar container. But we leave to the guys running the infrastructure to use. Linkerd was developed and open sourced by Spotify, so they're already using that in production for many years. It's a proven solution. So we don't have a winner yet, but I'd just like to tell you that service meshes are the thing that you need to be looking at, because they are going to be the default way of solving these problems in distributed systems. Okay, and that's what I wanted to show you for now. Hope you have learned a bit about Kubernetes and what is happening in the cloud computing world. And again, thank you very much.
Well, what did you think of that? I really hope that you enjoyed it. Just remember, If you want to become a member of the Dublin Java User Group, all it costs is €75. €75 gets you the entry for 10 events. It doesn't have to be the next 10 events, it could be 10 events over 3 years, but it lasts for 10 events. It's superb value to see all these guys in Dublin